Dear students, today we are going to study about thyroid hormones. In this session, we will study about synthesis of thyroid hormones, their storage and release, and regulation of secretion. So, let us start with thyroid hormones. In our body, we have thyroid gland. Thyroid gland is present at the base of the neck. This is a butterfly-shaped gland. This gland secretes two types of hormones known as thyroxine and triiodothyronine. Thyronine. This is represented by T4 and this is represented by T3. So, this gland secretes two types of hormones, thyroxine and triiodothyronine. This hormone consists of high concentration of iodine and are derivatives of an amino acid that is known as tyrosine. So, these compounds contain high concentration of iodine and are derivatives of an amino acid that is known as tyrosine. Now coming to the synthesis of thyroxine. Synthesis. In our body, in this thyroid gland, the cells are arranged in a circular form. We call this arrangement as follicle. Thyroid follicle. This follicle surrounds a fluid-like substance that is called as colloid. This colloid is present in this lumen and surrounding cells are known as follicular cells. Synthesis of thyroxine takes place in these cells. Synthesis takes place in 4 steps. Number first is step first. Step first involves trapping of iodine from plasma into these cells. Step first involves trapping of iodine, means the iodine which remains circulating in the plasma fluid gets trapped into the follicular cells. This is performed by means of a transporter known as sodium iodide symporter. Sodium iodide NIS symporter. This iodine is then transported into the lumen of cells by means of another transporter which we call as pendrin. So pendrin transports the iodide from the follicular cells into the lumen, while a sodium iodine symporter transports it from the plasma into the follicular cells. This is the first step of synthesis, means trapping of. Step first is trapping of iodide. Now coming, this was the step first. Now coming to the step second. Step second involves oxidation of iodide to iodine. Oxidation. This oxidation is performed by means of an enzyme known as peroxidase. So step second involves oxidation of iodide to atomic iodine, which is performed by means of an enzyme known as peroxidase. This was the step second. Now coming to the step third. Step third involves iodine gets combined with tyrosine to form monoiodotyrosine and diiodotyrosine. When one atom of iodine gets combined with the tyrosine, it forms monoiodotyrosine. However, when two atoms of iodine combine with the tyrosine, we call it as diiodotyrosine. So, step third involves the combination of iodine and tyrosine, which forms monoiodotyrosine and diiodotyrosine. Next is the step 4. Step 4th is coupling reaction. By coupling we mean two molecules of diiodotyrosine combine to form tetraiodotyrosine. So two molecules of diiodotyrosine forms tetraiodotyrosine. We represent it by as T4. Similarly, one molecule of diiodotyrosine plus one molecule of monoiodotyrosine combine to form triiodothyronine. Triiodothyronine. So this was the synthesis of the thyroxine, which is secreted by the thyroid gland. Now coming to the regulation of secretion. Its secretion is regulated by hypothalamus. The neurons of the hypothalamus secrete thyroxine regulating hormone. Means they secrete TRH, that is thyrotrophin regulating hormone, which stimulates anterior pituitary to release thyroid stimulating hormone TSH. This TSH, anterior pituitary secretes TSH and prolactin in response to TRH, which is secreted by the neurons of hypothalamus. So TSH stimulates thyroid gland. This TSH stimulates thyroid gland to release thyroxine. This was about the regulation of secretion. Means hypothalamus secretes thyrotrophin releasing factor, which in turn stimulates anterior pituitary to secrete thyroid stimulating hormone and prolactin. This thyroid stimulating hormone stimulates thyroid to release thyroxine and triiodothyronine. This was about the regulation of secretion. In normal body, near about 70 to 90 mcgs of T4 are secreted per day, and 15 to 30 mcgs are secreted of T3 are secreted per day, and it has been observed that T4 gets converted into T3 form because T3 is the most active form. T4 gets converted into T3 form. This is the active form and is more potent. While T half of T4 is 6 to 7 days. By T half, we mean the time taken to get reduced to its 50% of its concentration. It takes 6 to 7 days, while as T half of T3 is 1 to 2 days. 1 to 2 days. This was about the regulation of thyroid secretion. For further details, we will continue in next session. Thank you.